Assalamualaikum and hello everyone. Now we are in the topic of root of equations to discuss the example on bracketing method that we have on the bisection method and false position method. In this example 1, the mathematical operation is given and you need to solve the root value by using the bisection method. Alright, so step number 1 is choose the lower XL and upper XU root value. So in this equation, we already have the XL and XU value. Okay, XL is 0.5 and XU is 1.0. Okay, and then step number 2, we need to estimate the root XR value by having this equation XL plus XU divide 2. To the next step number 3, we need to determine the root lies either in the lower subinterval or upper interval by checking the multiplication of this fxl and fxr. So if the multiplication of function is less than 0, so the root lies in the lower subinterval, so we need to remain xl in the next iteration, while the xu need to be equal to xr. If the multiplication of function is more than 0, so the root lies in the upper subinterval. So the xu is remain while the xl is equal to xr. Okay, then we can terminate the iteration if the fxl multiplied to the fxr is 0, or we also can use the criteria of true error percentage and also the approximate error percentage. Alright, to solve nonlinear equation by using the bisection method, the first thing you need to check is you should have the equation, and then you need to choose the lower bound and upper bound value of root. So here we choose 0.5 for the lower one and 1 for the upper value. Okay, so we tabulate in the table. So we have the first iteration, XL is 0.5 and XU is 1. So now we can calculate the XR value of the root by average the XL and XU. So the answer is 0.75. So we put it in table. Then we calculate, we substitute the XL value of 0.5 into the function, and the answer of the function is 3.46 or 3.5. So similar goes to the XR value, we substitute into the function, which is the XR is 0.75 and the answer here is 3.78 or 3.8 in this table. And then we can multiply the function of fxl and fxr. Then we get the 13.12 as the answer here. Okay, next we need to calculate the true error percentage because we know the true answer or the analytical answer here. So by having this formula of ET, we calculate to get this value 23.78. Alright. I have made a limitation. If the true error percentage is 0.05%, then we need to continue. If less, we need to stop. Okay, so if the true error is still more than 0.05, for example here 23.75%, then we need to continue the iteration. Okay, so because of this first iteration need to be continued, then we go to the second iteration. Alright, for second iteration, we need to determine a new value of XL and XU before we can calculate the XR. So we need to see the limitation here of the function XL and XR. Alright, so here the first fxl multiplied to fxr is 13.1, which is more than 0. Okay, so if more than 0, we need to remain the xu. Okay, remain the xu, so it's same with the previous one. The value is 1. but the XL become is equal to the XR. That's why we are taking XL here is equal to the previous XR 0.75. Alright, so when we have the new XL and XU, we can calculate the XR by using the formula of XR. Okay, so here for the second iteration, we get the XR is 0.875. Then we substitute into the function for the XL and for the XR. Alright. Next, we multiply the FXL to FXR to get this value. So this is the calculation how to get the value of 9.403. Then we calculate the true error percentage by using the new approximate error, approximate value of XR 0.87. Okay, we make a difference between to the true answer or the analytical answer to get this is the new percentage of 11.08. Okay, because of this true error percentage still more than 0.05, so we need to continue the iteration. Based on this bisection method, the iteration is continue until fifth iteration. Okay, at this fifth iteration, the true percentage error is become less than 0.05%, then we can stop the iteration. Therefore, we can see the last answer of XR is about 0.984375, which is actually quite close to the true answer. Alright, for the second example, we will use the same function of fx to solve the root of equation using the false position method. Okay, I've explained in the concept of false position method. The step actually is similar with the bisection method, except in terms of the formula of XR here. For the false position method, the formula of XR is have the element of function of FXU, FXL, XL, and also XU. So once we have that 4 elements, then we can calculate the XR. Okay, after that we need to calculate in terms of the FXR here. And then the multiplication of the function XL and the function of XR. Okay, and up the answer is 4.36. As similar, we need to calculate the true percentage error. Okay, by using the formulas given here. Then we can see actually for the first iteration, the percentage of error is quite small compared to the bisection method, but still is more than 0.05%. We need to continue the iteration. So on the second iteration, to determine the XL and XU value is similar as before in the bisection method. And then we need to continue until the end of this column. Okay, so the percentage of error still less than 0.05%. Then we need to continue on the third iteration. Okay, so on this third iteration, we can see the percentage of error is less than 0.05. Then we can stop the iteration. So the last answer of the root value is 0.98394. Quite close also to the true answer. Okay, what is the difference or the advantage of this false position method compared to the bisection method is the iteration number is less. Okay, so it can say to obtain the answer is quite fast converge compared to the bisection method. Alright, that's all for the examples on the bisection and false position method, which categorize under the bracketing method. Till we meet again on the next topic. Goodbye.